Hello everyone, it's 10 o'clock sharp here in the Netherlands, so we're going to start with today's webinar. Welcome. My name is Eric Nijveld, co-founder and CEO of technologycatalog.com, the leading technology platform for the energy transition. In November last year, we announced the winners of the Tech for the Energy Transition Awards 2021. And our motivation for organizing these awards was to highlight the role of technology in achieving net zero. There were 5 award categories, and in today's webinar, we give the 5 winners, as well as the other 10 finalists, the opportunity to pitch their technology. And by the way, for those who didn't make it to the finals last year, we're going to organize another award competition this year, and more details will be announced sometime in the middle of this year. Before I move to the first category, few practicalities. For each category, we will first do the pitches of the finalists with 6 minutes per company. This is then followed by a brief Q&A session. And if you have any questions, you can type them in the Q&A box that you see on your left-hand side. And in case there's not enough time to address your question, then I would like to encourage you to contact the supplier directly. And an easy way to do that is to go to the technology page on technologycatalog.com and to type in your question via the contact form. The webinar will be recorded and you will receive a link after the webinar, and feel free to share the link with your colleagues. Radar and supporting technologies are in demand. I would like to hand over to the first presenter and the first company, also the winner of the category, HyET, hydrogen, based here in the Netherlands. And for this, I would like to hand over to Quinten Swanborn. So Quinten, your 6 minutes start here.
All right. Thank you very much for the introduction, Eric. My name is Quinten Swanborn, and I work for HyET Hydrogen. First and foremost, I would like to thank Technology Catalog for awarding us the prize in the Renewable Energy Category for our electrochemical hydrogen processing technology. Yeah, that is my main slide. So there's a lot that I want to tell you about our technology, but unfortunately I'm limited to 6 minutes today. So I'll dive right into it. So within the hydrogen supply chain, one of the biggest obstacles that we see is the high costs for compression and purification. Current technologies within the supply chain on these specific parts are quite maintenance sensitive, which is caused by moving parts. The maintenance sensitivity requires backup in order to substitute in case of failures. And at an overlying system level, you get a risk of leakage of lubricants for compressors, for example, in your hydrogen stream that essentially destroy fuel cells. Also, due to undynamic operation, you require oversizing of the components required, especially within green power energy systems. You have a lot of start-stop cycles that causes additional maintenance costs and additional installed buffer capacity. So these characteristics lead to a high total cost of ownership, which makes hydrogen still very expensive, unfortunately. Next slide, please. So at HyET Hydrogen, our current challenge that we see is getting hydrogen to end users for affordable prices. We do that in 2 categories, compression and purification, and we also do extraction and separation of hydrogen. Our value proposition basically focuses on reducing the maintenance costs of and the TCO of these solutions by supplying completely static equipment, so no moving parts, which leads to high uptimes, flexible turn down of 10% to 100%. We can compress from sub-atmospheric up to 900 bars, and because of redundancy installed in the system, no full backups are required. Also because it has no moving parts, it's completely silent. And with these characteristics, we can reduce the load, the total cost of ownership. Next slide, please. So the working principle, it's an electrochemical process. Our equipment consists basically of steel and membranes. So hydrogen enters the anode side and is split up into protons that pass the membrane and reform as high pressure hydrogen. This is a process that happens in parallel in each cell, and we produce stacks, as you can see in the third image above, that consists of that comprise these cells. And again, these stacks are put into a system and can be switched on and off individually, by which installed redundancy can be achieved and not using a whole additional system to substitute. For the electrochemical separation and extraction, the working principle is the same, but also from a mixed gas stream, we can selectively extract the protons of hydrogen out of the other streams. During this presentation, I will focus on the extraction of hydrogen from natural gas, but we can do this from other gases as well. Next slide, please. So first, to focus a little bit on the compression technology. Next slide. We have started out quite small and have now worked towards a commercial product that is the HES 100, 10 kilograms per day. So we've applied this in refueling stations already. And we're not stopping here. We're further upscaling to larger stack sizes, achieving 50 kilograms per day. And even not stopping there. So this is what we're qualifying this year. But beyond that, we want to scale with the market demand. Next slide, please. And as our stack scale, our systems in which the stacks are applied scale as well. So we now have 200 kilogram per day systems, but we're working towards, with our newer technology, towards systems that can do 5,000 kilograms per day. Next slide, please. Then to shortly touch upon some projects that we're working on now in the natural hydrogen extraction from natural gas. Next slide, please. So what we see as the future for hydrogen transportation is generating hydrogen using renewable sources, which can be injected in the existing gas grid. So it's blended in with the natural gas and then extracted at points of interest, which we can do very selectively with our technology to reduce the complexity and costs for hydrogen transportation. Next slide, please. So we have developed now several pilot projects in ranges of 10 kilograms per day. One is running in Sokol gas in California, and we've done one here in the Netherlands with Alliander and Kirion. So the proof of concept on the pilot scale has been achieved on those, and now we are working towards 100 kilogram per day systems for deployment in this year or next year. Next slide, please. So to summarize, we believe that using this technology, that's the traditional the obstacles that traditional technology brings can be overcome by energy efficient operation with our technology. It's compact, due to modular design, it's easily extendable. It is very robust against intermittent operation, so that is very useful also in renewable energy buffering. We can produce fuel cell grade hydrogen at the outlet, and due to the no moving parts, completely safe and silent. So this is what I wanted to share with you today. I know it's been very short and maybe a little bit hastily, but I will gladly discuss with you at another point. So feel free to reach out to my email or my cell phone. Thank you very much.
Thank you very much, Quinten. And indeed, a lot of information, but very interesting. And indeed, if there are any questions to Quinten, please type them in the Q&A box. And of course, also good to reach out to Quinten directly for follow-up discussions. So with that, I would like to move to the next presentation to Joep Breuer from Kitepower. Joep, over to you.
Yes, I hope you can all hear me. Thank you for the invitation of doing this nice pitch here. Well, this is just a nice picture of our system operation on Aruba, but I'll get deeper into it. Next slide, please. So what we actually want to do is we want to have a way to deploy clean, affordable, and sustainable energy to actually everyone. And we do this by using Kite. Next slide, please. We're a relatively small team, around 14 people, spin-off of the University of Delft, and founded well, more or less 5 years ago. And what we're actually doing, and that's clear on the next slide, we're producing, like I said, energy with Kite. Actually, our system consists of 3 main parts, or actually 4 if you would say. One, we have the ground station on the ground. That's where the energy is produced. That's where the generator is. Then we have the kite, of course, and underneath the kite, there's a kite control unit, which steers the kite like a guy under a parachute, left and right, and the tether to connect kite and ground station. And in the next slide, I'll show you a bit more how this works exactly. So we have the kite, which flies figures of 8. With this, it pulls very hard on the line, and with this, we slowly reel out our winch, which in the end we have on a drum. So reel out the tether, and with this, we produce electricity. At some point, of course, we're at the end of the line, and then we actually fold the kite. We make it more kind of a glider, and we very quickly reel in again. And with this, we actually pump our electrical energy. And this has a couple of major advantages, is that one, we can go higher than wind turbines. So we actually extract more and better wind up there. And the second one is that we use much less material. So the most expensive complex parts are on the ground. We don't need a big foundation. We actually need no foundation, no big poles or big blades. And so we have a very lightweight system, which uses more than 90% less material than a comparable wind turbine would. Next slide. So this actually fits really well in sort of the hybridization. You see that in off-grid sites, for example, on islands, that people use diesel generators, and they're now hybridizing, so that they're putting solar in there, maybe some batteries. But in those locations, it's often difficult to also add wind to the mix. And solar, of course, is limited to only the day, and that suits very well. So that would be our first market where we're aiming at. Next slide. And this is where we start, relatively small, with a 100 kilowatt system. This is what we're now running. We have 2 of them operational. And then we'll actually grow. Of course, we want, like I said in the first slide, we want to make an impact on the world. And with this, we have to make the same journey as windmills did. So we grow from 300 kilowatts to 500 kilowatts, and in the end to megawatts. And in the end, you would see our systems also offshore. So in areas where now wind, again, is not an option because the sea is too deep and you have to work with floating platforms, this would be the way to go to save a lot of energy and also make the installation much easier. Next slide, please. But that's sort of the far future. We're now sort of scaling this in multiple locations. So we're actually actively looking for pilot customers or pilot projects where we can deploy our 100 kilowatt systems and sort of make those final touches up on the product. And that would be my presentation.
Thank you very much, Joep. And again, if you have any questions, please type them in the Q&A box. And before we go to Q&A, we'll go to the final presentation of this category to actually to our neighbors here in Delft, to Willem van der Merwe of Amphibious Energy. So Willem, over to you.
Thank you, Eric. Yes, thank you for Technology Catalog, for nominating us, and also, that we've been in the final, one of the final awardees in the section, especially as you said, Eric, with the amount that have taken part in this. It's quite a privilege. So Amphibious Energy, yes. So we're the company that focused over the last few years on building, constructing the EnergyPods. These units that you see here in front of you, that's what we call the monopods. And what we've done is, next slide, yes. We've over the years we've identified the issue in the offshore sector with smaller, and the use of the smaller gensets, especially diesel gensets in the oil and gas, offshore wind, aquaculture, and the maritime sectors. due to the fact of using these diesel gen sets, which have a heavy carbon footprint, but it's not only stopping there, it's also about the maintenance footprint and the costs around it, so it's a heavy cost power utility. And that's what we focus on to see how we can compete with this or provide an alternative for these markets. Next slide, please. So hence the design of the EnergyPod, quite simple. It's not a complex technology. It includes our own Nautilus offshore wind turbine, combined with solar, combined with storage entity, currently using batteries, but we also can use other storing facilities. All containerized, single lift unit, which can adapt in size. With various options. The one that you see on top is basically the monopod, but we also got sun pods. We also got twin pods, quad pods, with bigger units, up to 40 feet container. The unit is adaptable for any environment, and we have monitoring systems on them as well, continuously 24/7. Over 200 sensors sitting within these units. So we're having a lot of data coming in, but it gives the client basically carefree operations. And it's a low OPEX unit as well, virtually maintenance free over a period of 5 years. Next slide. So deployment, we focus quite a bit on the deployment because normally with renewable energy and especially small scale renewables, it's quite complex to install it on these smaller facilities. You need space for solar panels, you need space for your turbines, and then also space for storage. We've decided to do it all in one, make it a single lift unit. Deployment on that oil rig that you see in the upper image is a decommissioned platform up in offshore Scotland that we've supported for more than 12 months. Basically, the deployment was around about an hour, and commissioning and power to the platform was another hour. So within 2 hours, the whole unit is installed. So it's saving costs, saving time, and offshore, risks for people out there as well. With that, the unit is also can be used on multiple sites during its lifetime. It immediately can be decommissioned and moved to another facility to support. It's also recyclable. Small updates that we can do with the units back on shore, and then it can be redeployed again for the next client in the next environment. Next slide. So for which we support the markets is basically oil and gas sectors, especially platforms that's in lighthouse mode that requires power, but also offshore wind. We're supporting with all the auxiliary power, but also we've joined recently with the technology of corrosion, ICCP technology in the pod itself, so we can support offshore wind farms. By providing then power for the corrosion protection, but then there's simultaneous power for cable pulling, navate and other facilities or appliances as well on these monopiles in the waters. But it's not only stopping there, it's also, we've recently, the image below is sitting it now, our technologies is now joined with offshore floating mussel farms, fish farms, supporting their power needs as well. And then also the shipping industry, integrating this technology within the vessels and supporting their mooring power, nearshore power. So there's the 4 key markets that these units can be deployed and redeployed. It's not that we only deploy one type tech to the one market. It can be switched around, move about between these markets. Next slide. So basically, the key benefits of these units of ours, it's proven tech, it's operational already. We can produce, at this stage, our facilities can produce up to 200 units in a year. It reduced carbon footprint around about 43 to up to 50 tons CO2 per unit per year. It basically operates half the cost of what a diesel genset is operating at. So it's a cost-saving entity as well, not only then lowering your carbon footprint. So we're not only ticking the box of environmental, but also actually really saving costs for the industries as well. Already mentioned about the deployment duration. We de-risk and reduce that, and also simultaneously the offshore risk of people due to the fact of the short installation and deployment time for these units. We leasing the units as well as purchase the units, so you can buy and you can lease them. So it's a flexibility, so you don't need to own another asset. Actually, that's also giving the industry quite a bit of flexibility. Due to the fact of including an old existing tech like corrosions ICCP tech inside the container now, can we also then reduce steel and coatings for the offshore wind industry? So it's eco-friendly corrosion protection that we offer them. The units operate autonomous and it's fully basically a circularity unit. Yes. If you want to have more information, please feel to contact us. Also visit our technology catalog page as well. We'll update that on a regular basis as well. Thank you.
Yeah, thanks, Willem. And actually all three, there's a bit of an echo. Actually, all three presentations that you heard just now came from the Netherlands. Perhaps nice to mention that in total we have presentations from 9 different countries today. And we got submissions from in total 20 different countries, so truly international. So there are a couple of questions coming in already. Let me start with the first one for HyET. Could HyET technology be used for small-scale applications like hydrogen fuel cell vehicles? Quinten?
Yeah, that's for sure. So we do not necessarily do the storage and fuel cell application. So we are in front of that in the supply chain, and we do the compression. So from our compression, we can compress up to 875, which is required for refueling stations. And then from there, it is filled into personal vehicles at 700 bars. But indeed, our technology can be applied for that.
Okay, thanks. The next question is for Kitepower. You say you can go much higher than wind turbines and you can operate in the dark to compete with solar. How do you, or have you, no, let's phrase it this way. How do you engage with aviation authorities or offshore, onshore installation and other relevant authorities to ensure that the kite does not interfere with other traffic?
Oh, we apply for a permit. That's easy. No, of course, there are some boundary conditions there. Currently, we're actually seen within EU regulations as a drone. So there's a lot of new regulations there, and this makes it possible to operate our system in a lot of spaces, except probably very close to airports or low-flying military zones. But even in the crowded airspace of the Netherlands, we can still find quite some spots to operate.
Okay, excellent. So I can indeed well imagine that the deployment of drones across the world has helped to pave the path for you then.
Yes, true. Yeah.
Yeah, excellent. A question to Willem. What's the maximum power of the pod per pod?
Well, Eric, yeah, it depends on what size of pot they are asking about. So if we start off with a monopod, the small one, that is, and the batteries we include is 86 kilowatt H unit. So your peak capabilities for short durations is up to 30 kilowatts in power, and your continuous load capabilities out of the small one is between 500 to a kilowatt. But if you move to the bigger ones, the quad pods, then you're talking about more than 0.5 megawatt of storage in it, and up to 4 or 5 kilowatts of continuous load out of that. Okay. So it depends. It all depends on the user and what their requirements is in power. So that's the type of questions we normally throw back to the client to ask exactly to provide their load list, and then we can configure the units for them. Okay, so there's a degree of flexibility and you can tailor to the needs of the customer. Excellent. Let's go back to Quinten for questions. So
noticed indeed that your things ongoing in all the way in Los Angeles and here in the Netherlands. So that's quite geographically spread. Can you say something about where you typically see the interest for your technology coming from?
Typically, really worldwide, but where we see it upcoming a lot now is Southeast Asia. So there they are really pushing hydrogen as a new energy carrier into the industry. So you see there that refueling stations, for example, high pressure refueling stations, they are heavily subsidized. And that is for all the hydrogen producers there. That presents now the best business case, because you can sell hydrogen relatively expensive if it's used for refueling purposes, and industry not yet. But also, for example, in Germany, you see that the chicken or egg discussion is tackled by simply pushing a lot of refueling stations, so that people that are doubting to buy a fuel cell electric vehicle do not have the issue of worrying about whether they will be able to refuel or not when they go somewhere.
Yeah, thanks. Very clear. Question to Joep. Joep, can you say something about the economics of Kitepower and what's your sort of sweet spot?
Well, currently we have a relatively small scale system, although sort of 100 kilowatt, we can still provide sort of 150 Dutch households. With this system, we can deliver sort of between 10 and 15 cents per kilowatt hour. So we cannot compete with, big wind turbines as is. But if we upscale and sort of make the same journey as actually solar and actually also wind turbines did, then we can also get into the same range.
Yeah, excellent. And question to Willem. Willem, you mentioned that the pod can be of interest to multiple industries. Can you say something about where most pool is coming from at the moment?
Sorry, Eric, just repeat that last part of your question. Where most
interest is coming from?
Oh, the most interest, yes. So most interest is from the offshore sector at this stage, because it's the most hardest rich and most remote part, of the and where they have the most power needs as well, small scale as well as large scale. So yeah, at this stage is mostly, and the other thing is for wind turbines. Yeah, wind is also, one of the most important sources for your power management within our system. So offshore is also your most idealistic locations for these, especially the smaller type of turbines that we're utilizing here.
Yeah, excellent. We have no more questions in the Q&A box. Any concluding or final remarks from any one of you before we move to the next session?
Yeah, if I may ask a question to Kitepower, I was wondering, how do you deal with excessive weather situations, for example? Do you have protocols in place to recover a kite in case a storm happens?
Yes.
What are your procedures?
The wind range is quite wide. So we actually, because kite flies much faster than the wind in these figures of 8, so we can easily handle wind loads up to, I would say, 30, even 40 meters per second. So that's already quite decent. Also to the low range, by actually putting a bit of energy into the system, we can actually keep the system airborne with little to no wind. And actually we see there's an advantage, especially if you look, for example, the Caribbean, there's the hurricane belt, and it's difficult to place solar panels and wind turbines there because you have to design them for these very, stormy conditions. And we have the advantage that if such a case would come once or twice a year or something, then you can actually land the kite, you can pack it, because the kite itself is just a very small volume, sort of wait for the storm to pass and then be operational within sort of an hour after the storm is gone. But there's actually a big advantage in those first areas where we want to go to.
Thank you. Very, very interesting technology.
Yes, thank you for the question.
Excellent. So that rounds off the the second category around renewable energy today. So 15 great presentations. And also thanks to all the attendees. And hopefully you will leave this webinar with many ideas on how you can improve your performance and realize your goals with technology. And we will continue to create visibility for technologies via the platform, technologycatalog.com, such that companies can find and select the right tech to improve performance. So with that, many thanks, and I wish you all a great rest of the day.